changes in the sun. You actually have changes in the amount of heat, the amount of energy that the sun is giving off over time. And these solar irradiance changes can occur on scales of days to hundreds or even thousands of years. For instance, the sunspot cycle, which lasts about 11 years, currently we're at a minimum, and the sun is very quiet right now. There have been very, very few sunspots seen in the past year. 2008 was actually the quietest, least sunspot-ridden year of the past 55 years, I think. I think it was 1954 or something like that, when scientists actually saw so few sunspots on the Earth. On the sun. So that is actually hypothesized to be one of the reasons why we're having a very cold winter this year. The sun, when it becomes very quiet, when it doesn't have these active sunspots on it, when it's not putting out as much energy, actually is not heating the Earth as much, and so the Earth cools just a little bit. So right now, we do have a very quiet sun. Now in the next 3 or 4 years, that should ramp up. Theoretically, according to past records of the sunspot cycle. So we'll see how that goes, and whether the sunspots start appearing again, and whether the climate warms consequently with changes in the solar irradiance. The Earth also changes in relation to the way it goes around the sun and the way it's pointed at the sun. These are very complicated cycles that last tens of thousands to 100,000 years, and they're called the Milankovitch cycles, and they are assumed to cause the current glacial, interglacial, ice age cycles. This is going to take up an entire lecture, so hopefully, I mean, if you're interested in learning more about this, there's lots of information on the web. I'm just going to go past it quickly, but the general gist is that the way the Earth is inclined with respect to the sun and how far away it is from the sun affects how much insolation it gets, how much radiation it gets, and where that radiation hits, whether it hits at the equator or whether if the Earth is pointed more toward the sun, whether the pole is pointed more toward the sun, it might get more heat and energy at the poles, and that melts the ice that's there. So it's a very complicated and subtle system. But still, it seems to be the one that's driving the hothouse, ice age cycle over the past several million years. Ocean currents can change. There's an ocean conveyor belt. A lot of you may have heard about this. The thermohaline circulation of the ocean, where warm and salty water dives down here in the North Atlantic and travels through the bottom of the global ocean to the Indian and Pacific Oceans, and then travels back as a warm surface current over the surface of the ocean. This is thought to have about a 1,500-year cyclicity. It takes about 1,500 years for the water to go from here to here to here, and they've measured it via lots of oceanographic research cruises. Back in the 70s, actually, is when all this understanding began. Volcanic eruptions can happen at any time, and they can make changes on scales of days to years. If it's a really huge eruption, they can put lots of aerosols into the high stratosphere and actually block solar insolation for a couple of years,